All right, let's do a quick review of the basics of projectile motion. And along the way, let's look at a particular special case where we have some nice symmetry. So you'll look for this in some of our problem solving whenever we have an object that begins and ends over level ground. We can take advantage of this. So we have something being launched at a velocity v naught with an angle theta. We know it travels in the shape of a beautiful parabola. If we consider it at a few different points on its journey, we know characteristic of all projectiles, the x velocity, the horizontal velocity, will stay constant, nothing to change it in the horizontal direction. Whereas in the vertical direction, our velocity shrinks to zero and then begins to grow as it changes due to the acceleration of gravity. And I want you to notice about this case where it goes up and down and ends at the same level is we have symmetry such that the one half of the parabola looks exactly the same as the other. And therefore we can say that the theta that it's launched with, if it's launched at 20 degrees, it's going to land at 20 degrees. We can say that the time it takes on the way up is equal to the time it takes on the way down. And you'll also notice that the landing speed ends up being the same as the launch speed. So let's look for this sort of symmetry whenever we end at the same height. Take advantage of that. Also, we can here define this term range. When we say the range of a projectile, we're talking about how far it's gone before it lands. So surely there must be some sort of a connection between the launch angle of a projectile and how far it travels, or what its range is before it lands on the ground. Well, it turns out that there are two factors that go into determining the range at which a projectile travels. The first is the hang time, the amount of time the projectile spends in the air. And the second is having horizontal velocity. So let's take these each one at a time. Starting with hang time, we think about how long the projectile is in the air. This is only determined by the vertical portion of its motion. The y direction is fighting against gravity, and only the y direction keeps our object in the air. So a 90-degree of vertical launch would give me the best hang time. Even though it might not go anywhere, it would stay in the air the longest. That's not the only piece of the picture. The second part, of course, is the horizontal velocity. You got to be in the air, but you also need to move sideways during that time. So having a 0-degree launch, like this golf case, might give you a lot of horizontal velocity. However, really it's the combination or the balance of both that is desired, a balance of vertical and a balance of horizontal. And this is where the 45-degree angle comes in. In theory, with no air resistance over level ground, no launch angle, will give us a better range than 45 degrees. It's the perfect balance between hang time and horizontal velocity during that hang time. Another interesting aside is that any two angles that are the same distance or the same separation from 45 degrees will yield the same range. So there's 45 with my maximum range, and a 30-degree shot may be very shallow, and a 60-degree shot may be very high. One of them has a lot of hang time and not much horizontal, and the other has a lot of horizontal and not much hang time, but the effect ends up being the same. So any two angles that are complementary will give the same range. So a 10 and a 90 degrees will give the same, or excuse me, a 0 and 90 will give the same range. A 10 and an 80 will give the same range. A 30 and a 60 will give the same range. And we could also consider the case with a projectile that isn't launched over level ground. So what happens if a projectile is landing on top of a hill or a building, or a projectile is being launched from a cliff and landing down below? Well, 45 doesn't necessarily give me the longest range anymore. And the best way to understand this is think about it in terms of hang time. The one that lands on the building loses some hang time because its flight's cut short. The one that's launched from the cliff gets some extra hang time because it can fall farther once it reaches the original height that it was launched from. So taking that into account, the one that loses hang time has to be shot at a steeper angle than 45 degrees in order to give it its maximum range, to give it that extra hang time that it needs. And the one that has the extra hang time can be shot less than 45 degrees in order to get the longest range, to take advantage of that extra hang time with more horizontal velocity.